Hello friends, welcome you all once again in lecture series Manufacturing Technology. I am Amit Tiwari, Assistant Professor, Department of Mechanical Engineering, Suresh, Gyan, Vihar University, Jaipur. Today is the 16th lecture of this series and the topic of the today lecture is metal forming process. The objective of the lecture is to obtain a finished surface in order to avoid expensive finishing. Metal forming processes are classified according to the effective stresses and the forming under first compression, second a combination of tensile and compression, third tensile, fourth bending, and fifth is shearing condition. So the today lecture we will discussing of all these parameters and how we can fabricate fabricate a metal or to be formed in a desired shape by the forming of cold working, hot working, or any other type of processes in the this metal forming process. The outcome of this lecture at the end, the student will able to understand about metal forming processes, including no wastage of the raw material, better mechanical property of the product, and faster production rate. Machining is the process of removing the material in the form of chip by means of wedge shape tool. So basically, what happened that during the machining or time, or we can say that the raw metal when we are doing the metal mechanical property, if the idea we have fabricated for any material and to increasing the metal mechanical property of that particular product. So it will be doing some interactive operations so that will perform to the metal forming processes. It will be happen, and after that, the student will be able to understand how the mechanism will be occur to machining process to remove the material from the chip and by means of wedge shaped tools. So the introduction of this metal forming process that we know that the materials which are covering under the scope of the material science are available under from the nature or industry. However, this material cannot be used in the raw from the for use purpose. So basically, what we know that is during the machining process, we thought that the metal will remove in the formation of chip, and this chip is just formation of chip, and the chip are just part of the wastage of material, which is not reused by the any industry. So, but now in the days there are some recent inventions are available that is to recycle that type of chip to making the composite material or to reuse the chip by melting this type of chip and make a mold and to make some casting product from the available of the chip. So these are the some options to be find out the some various techniques to be formation of the any product. So although we know that they have to some shape and form in the article that through the particle manufacturing processes. Beside these are some processes which improve the material properties. In some processes, the materials are changed into their primary forms for some selected parts. In some cases, the materials are suitably finished for commercial usage. In other cases, neither surface finishing or the dimensions are satisfactory for the final product, and the further work is necessary. However, the selection of the best processes for a given product require knowledge of all the possible product methods. So these are the some terms basically we are discussing about in the metal forming processes to how to finish the material and how to use that recycle the material for increasing the surface finishing or give the satisfactory final product. Some important processes are listed below, which are working on a very different operations are performed in a particular operation, and to give the shape and dimension as per our requirement during the manufacturing of any product. So the some important processes are listed below. That is the first is the cold working. In cold working, there are the seven type of operations are performed. That is the drawing, sequencing, banding, shearing, hobbing, short pinning, call extrusion. These all are the technique basically we are discussed in the cold working processes. How the drawing, bending, and hobbing. These all are the doing such operations in the cold working form. Second one is that is the hot working. There is operations are also for considered. That is the rolling, forging, pipe welding, hot processing, hot drawing, hot spinning, and hot extrusion. All are the part of the working. Where that is all are the considered where the material will be working as a operation to pass the hot working operation and cold working operation for mechanical property increasing to enhance the property of mechanical or any other properties of material that is will reduce the or diameter, or by increasing diameter, or by making the too much strength to providing for that. So we provide some hot working and cold working for that. So it is just basically now it is very popular to enhance, and these are the latest technology adopted for the material fabrications persons who are working on the field of metal manufacturing technology and working on the metal formation. So these are the forming time. Forming, that means it is the form, give the some advanced formation, or give the some desirable shape and size as per the our desired conditions what we want to giving the some suggestions for that, improving the mechanical property. Suppose for example, if you are doing we are making for a rail steel, then you need to the hot cooling and cold cooling both for increasing the material strength of the rail. So these all are the hot working, cold working operations are very important for that point of view, for increasing the mechanical properties, or to we can say increasing the strength of the material. Third one, that is the forging, which where the two type of forging technique. That is the first is hand forging, another one is the machine forging. Hand forging and machine forging, these are two techniques. Basically, we are used for that. One is the hand forging, where to with the hand, with our hand we are doing the forging operation, and by the advanced machining we put the material from the machining, and the forging operation will be performed as per the our giving command. Fourth one, that is the casting, already discussed in the our some previous lectures on the manufacturing technology. That is sand casting, shell molding, permanent molding casting, die casting, centrifugal casting, investment casting, plastic casting, slug casting. Yeah, the various type of castings are available nowadays to improve the quality and improve the design form, and to fabricate a very design as per complete design or the simple design. We all are fabricated by the now the casting, and there is star casting techniques are available for making the composite material. So there are the very types of techniques are available for making the for forming the process product. That is metal will be forming processes are in the category of this type of castings as per the industrial applications. So therefore the requirement of machining, we will be produce we will be join this type of technique for the production of material. For the mechanical working process are used to achieve optimum mechanical properties in the metal. The metal working reduces any internal voids or cavity present, and thus make the metal densest. That is, we know that there is a use to achieve the optimum mechanical property. So the ultimately sole objective of this lecture, that is to how to increasing the mechanical property, how to enhance the material property which we are working on that particular after the completion of the product. Suppose if you want to make a product who working under the various stresses, that is the rail steel. If there are various stresses are acting on it during the when the rail steel are working on the platform. So at the time, what we have, we do the strongest material, which is the more harder than the we can say that their ultimate strength will be producing, their hardness will be increasing. So these all are the, we can say that minimum or maximum stresses we consider. For the minimum stresses where the metal will are beer, and for the maximum stress where metal will break. So these all are the conditions will occur during the machining process. It will be under the category of formation, but will optimum mechanical property will be increasing. Our whole objective is to the PPT is to show presentation of this lecture, that is to increasing the material property by increasing the forming operations, and by increasing the some reduction the internal voids, some cavities where present in that metal, the metal defense. The impurities in the metal also get the elongated with the grain, and in the processes get broken and dispersed throughout the metal. So these are depending upon the conditions of where how much impurities are presenting on the metal, and but which ratio are present in what type of impurities are having. So there are sometimes we can say the corrosion problems are having the consider. So there are different type of corrosion conditions. So what type of conditions are having the particular material. So at the time that there will be we will be solve this particular problem for the particular corrosion we have. So this decreasing the harmful effect of impurities improve the mechanical strength. So by removing this all unwanted impurities, we decreasing the we can say the impurities, or for increasing the mechanical property, or to increase the mechanical strength of the material, which is our desirable form to any industry. If you are working on the metal forming, we can say working on the manufacturing industry who continuously work with the casting or this type of processes we have, so that we conduct for such type of material for the how do we increase in the mechanical property. the option is that. So there are the many options, there are the many suggestions we are providing for you to understand the mechanical properties of that particular material, which is the more effective, and this decreasing the harmful of the impurities and improve the mechanical strengthening of the material. So at that when the material line that you can consider that a paragraph that is of material when material are subject to external load, which is the material are subject to external load that get deformed. So at the time of the external load, the load are subjected on the material, they got deformed because they have not too much capacity. They are not bearing the too much capacity because the limit is fixed. Because if you are using if you are applying the 500 Newton load and the material having capacity only to bear the 300 Newton load, so it easily break. So you just manage the property of the material by increasing the reinforced material, increasing or by increasing the some hot rolling, cold rolling, by giving the amount of heat treatment of the particular material to increasing the load capacity or strength of the particular material. So the deformation may be elastic, or there are the different type of deformation. That is, it may be elastic deformation, it may be plastic deformation, or it may be the fractional deformation. Because in elastic deformation, as you know, so in the stress strain diagram, that is the how much load are applying, and during this how much elongation are on the changes on the material property. So you can find out about the elastic deformation. That means when the material started to take the load and bearing the load, and have a limit to do not overcome the material strength. That is, after some time that you may be applied a more load, and then it completely convert into the plastic resin, where the material do not regain the shape another after removing the load. So that time the elastic limit are over, and the plastic range are starting at the plastic range are continuously continually hold on until the material not break. When the material is starting and the crack formation are here, it indicate that the fracture induced for the internal cracks or shown in the material. It indicate that the plastic deformation are overcome, and the fracture, that is a ultimate we can say that close the ultimate tensile strength that will material after some time material will be breaking at any point. So it depending upon the loading condition, depending upon the properties of the material, elastic deformation is said to be have the occur. So depending upon the load, basically what type of load are applying and how much quantity of load applying on a particular point, and what are the properties of the material, the property of material have a capacity or not to bear the such type of load. So if the property of the material have not capacity, or we said that the not made up of for such load, then it easily to break because they have not capacity to bear such type of load on the surface of the material. So the elastic deformation is completely said that it will be occur first of all, and after that it will be converted to plastic, and that fracture will be occur. So what we do the depending upon the loading and the properties of the material, and plastic deformation is said to be occur. So when the material returns to its original shape, it removes after load. When it does not return its original shape or remove the load, it varies a new configuration. Definitely, when you first of all, when you applying the load on this particular material, and if the after removing the load, if the material will regain the shape, that it means they are in the plastic zone, elastic zone. And after applying the load, and after removing some time, that is not recovered by the original position, that means it completely goes to the plastic deformation, and new configuration are to be obtained. So the material goes to be deformed permanent plastic. It will not regain the shape again, once again and again. After some time, because every material have a limit, every material have elastic limit, every material have a plastic limit, and every material have some ultimate tensile strength. After that, there will be a break at any point, at any time. It will be happen there. So the further deformation causes the material to fracture, resulting in the separation of the part of a material from the body of a material. That will happen. So in the metal forming process, basically the use of the metal forming is to increase the mechanical property and reduce the impurities. And how do we make the mechanical property increasing? It will be discussing in this unit. That is unit 3, that is metal forming processes. So this unit is basically helpful to understand how to increase the mechanical property and what are the operations performed on to increase the mechanical properties. What are the basic structure we use? What are the route we use selected for the particular operation, and how we can improve the quality of the product, and how we can improve the strength of the product, how we can improve the such particular property we want to increase in the thermoconductivity, density, or we can say that the toughness, hardness, ductility, weldability, malleability, what type of property we want to increase in. So these are the selection criteria we will discussing on the today, as well as this unit 3 in the lecture series of manufacturing technology. So what is the plastic deformation? The plastic deformation is the deformation which is permanent and beyond the elastic range of the material. The first line indicate that. Plastic deformation is the deformation which is permanent deformation. Because we know that the permanent deformation, if the permanent deformation occur, that means it will not regain the original shape again after applying some load. And after the permanent deformation, it will be break and cause the ultimate tensile strength for the particular material. So often when the metals are working with the plastic deformation, because of its beneficial effect, or we can say that is important to the mechanical property by it. So the necessary deformation in the metal can be achieved by the application of large amount of mechanical forces only for by heating the metal and by applying a small process to it. So there are some type of we can say that every metal have elastic limit, every metal have a plastic limit. But how we can get that this is a plastic limit of particular metal? We just check by the use of ultimate tensile strength. We can find out, but by the help of the universal testing machine, testing of the universal test, or by the find out the some hardness by the Vickers hardness test, the Bindle hardness test, Rockwell hardness test. It totally depends upon the material property because when you are applying the load on particular material and you have not aware about the what property of that particular material which is used to for the operation, then it is very difficult to it will chances to failure that particular material you are selected for the operation, because most of the time you have to aware before starting the operation, because if you select the material for tensile stress and you have a load applying the load that is 500 or 10,000 and 1000 we can say that a different number of loads, and the metal have no capacity to be at a certain load. So what happens? It easily break. It is easily break because it have not met from that particular load. So for that, you just keep in mind that during the testing or during the operation, first of all, check the properties of the particular material before applying the load or before applying any operation for that. Because the plastic deformation is completely, if the plastic deformation is occur and if the material are doing the testing and it will not regain the shape, that is the wastage of the money and wastage of the power, and as well as the wastage of the material you are testing for that. So during the machining process, you just keep in mind that the plastic deformation is the most important, that is to find out the strength of particular material, because of how when which load of which load the material will goes to the plastic deformation permanently. That particular load is the ultimate tensile strength of the material. So these are the fundamentals. These are the fundamentals. These are the basic principles you to understand during the experiment or during the any testing of any material, or to perform any formation test for the particular material. And it have to be increasing the load, and it will decreasing the load, and deciding upon the mechanical property of such material you are using for the operation. So the working, that is the cold working and hot working, now discussing here. So first of all is discussing the cold working. What is cold working? Cold working, or the definition that are different authors that are the first is when plastic deformation of metal is carried out at a temperature below the recrystallization temperature. The process is deformed on the metal at term of the cold working. When the plastic deformation of metal is carried out at a temperature below the recrystallization, that is again they are not doing we can say that convert the original shape. The temperature process performing in the metal are called the deformation, or we can say that cold working is the process of metal forming in which deformation of metal occur below its recrystallization temperature. In most cases, we perform cold working of metal at the room temperature. So these are the definitions of the cold working. I hope you understand. And the various cold working processes are: first is a drawing sequencing, second bending shearing, third hopping short pinning, fourth cold extruding, etc. So these are the we can say that is the four type of cold working processes are having in the terms of cold working. So we will discussing one by one. So first of all, just keep in mind is a simple definition, that is when plastic deformation of a metal, that is when the deformation occurs on the metal is carried out at a temperature below the recrystallization temperature. Below the recrystallisation temperature, if you are doing the perform on metal, it completely plastic deformed during the operation. It not the cold working. So as you see in the diagram, that is a cold working process are here. That is, you can see this is a workpiece. This is a workpiece. These are the lower roller, and the upper, that is part is a upper roller. So there are two type of roller, upper and lower. So in this, what we do, there's new grain structure of formation by the, you can remove, you can just run the roller on surface of the workpiece upper and lower part, and where you can say that the new structure of formation here, that is the new structure gain of form, rather than this. These are the oldest and these are the existing, and you can perform the operation on the work metal on the workpiece. That is the called working process, and you can find after some time that is the called working process are held on, and the new grain size structure are formed. And this new grain size structure has shown that the metal is regain the shape and just increasing the quality of the workpiece with the help of the cold working process. So when you are applying some particular force on that roller, because the roller are just running on some certain RPM, and also the force are applying on the particular material from the upper and the lower part, and some upper stresses and some lower stresses are act on the material, and it reduce the diameter of the particular material due to the compression process applying on the particular area. Due to this, the material are just decreasing the diameter of that particular, and that existent that a new diameter which are formed, it is a new formation of the material, that we can say that the new grain and the structure are to be obtained from the point of material, which will be are under the category of the cold rolling working process. So generally it will doing the such a working because during the rail track, because rail if you are making the rail, that is that this cold working and hot working are very necessary to, because it will maintain the shape of the particular rail, yeah, which are standard shape designed for the railway industries or any steel industries for fabrication the rail. Because we know that the many of the industries are working on the making material strong, but it's not we sometime a part of understanding the internal microstructure of the particular material, because the internal microstructure is not aware where that is, it will be difficult to find out how we can improve the material by addition of some particular reinforcement or by addition of the some you can say that some apply the some load particular, how much load will be applied, because if we apply too much load and the material will reduce too much, which is not required, we require a certain amount of the load are applying for a particular area, which is the part of the material formation, metal forming by the help of the cold working processes. So these are the some benefits we will be provided for that. Advantages of the cold working are, that is first is the handling of material is easy, it has some advantages. Second is a good surface finishing and better dimension accuracy. This all are the handling it is very easy, it is not difficult in the task. Second, it is a good surface finishing and better accuracy we are providing for the with the help of the good cold working processing. Third is the energy saving, since heating is not required, because when the heating is not required, it is the energy saving, it will be done by the cold working only. Strength and fatigue and wear property are improved. By this cold working, the basically strength, fatigue, and the wear property of are improved. That is improving the hardness also, as we said, hardness and toughness. So fifth is a minimum contamination because of low working temperature. So minimum contamination, that means we said it's working on the very low temperature easily, and it will not be to take too much time for the conversion of another shape. So it will be the minimum consumption we use for the working temperature, low working temperature. 6 point, it is no possibility of decalibration of the surface, because it completely work and to change the dimensions, and it has the new grain size are obtained on the surface of the material, which is that there's a new drastically changes are here, and there's a new formation of grain size are here. So it will help you to understand that the no possibility of discarbonization of the material surface. It is a good part of the cold working. So economically for small sizes, it will be used for the economically small sizes, because this will easy to understand, easy to we can say build the material, or we can fabricate the material, or we increase in the quality of material, which by economically are very easy. Eighth is highly suitable for mass production and automation. Eighth is highly suitable for the production and the mass automation because of the low working of temperature. Ninth is the physical properties of metal that do not respond to heat treatment can be improved by the cold working. So these are the physical properties of the metal who do not respond by the heat treatment. It can be treated by the improved by the cold working processes. So these are the some advantages. So basically, we are doing the some type of operation for that. So this gauge sheet we can say that can be produced with the help of the thin sheet we are producing from the cold working, because we increasing the diameter we have of the material and we reduce it by the coiling roller. Roller are the upper roller and lower roller are removing the unwanted area which we are not required for the dimensioning. So it will be reduced by the thin gauge sheet from the can be produced. So these are the some advantages of we can say that for the cold working processes we have. So these advantages are producing by the mechanical energy, or we can say mechanical efficiency. We will improve. We will improve the some type of we can say that each and every property, what the property we will discuss, it will be improved by the cold working processes. Yes, obviously there are some also disadvantages because during the working day we also facing some disadvantages such as are follows. First is the ductility of metal is reduced, because during the cold working, too much amount of cold working if we are doing, that is the ductility will be reduced. So metal of the ductility, so it will be chance that the ductile metal will property will be reduced of the metal, because cold working if we are doing continuously. Second is the deformation energy require is high. Deformation energy requires high, so rugged and more powerful equipment is required. Deformation energy required is high, so rugged and more powerful equipment is required. Thus we can say that thus equipment's cost is very high. Third, it is several stresses are set up. This requires stress relieving, which increase in the cost, or we can say that owing to limited ductility at the room temperature, the complexity of the shape that can be readily produced limited. So these are some points to be considered as a disadvantages of the when you are working on the cold working. So we have a lot of advantages, but some disadvantages also facing due to this type of problem we occur. Fifth, that is the cold working for large deformation. Cold working for large deformation requires several stretches with inter-stretches annealing, with which increasing the production cost. The cold working for a large deformation requires several stretches with interstretch annealing, and which increasing the production cost we have. So these all are the properties we will discussing on that material, which will be indicated by the various we can say that the cost production is very high, because we require some special we can say annealing or processing, or we can say a special material we required for the particular operation. For it production rate is very high. Due to this, we will be managing such type of operations for that. That is for reducing the first of all we preheat the material before the cold working. So it's easy to understand with defecting of the part. Now the following points are worth nothing. That is, the first is regarding the cold working. The first is cold working produce an important surface finish and closer dimension tolerance. Cold working produce an important surface finishing and closer dimension tolerance, and because of the characteristic, cold working processes are generally used in the making end use product. So these are the some worth nothing point or noting point mentioned for regarding the cold working. Second, that is the sense recrystallization does not take place in cold working, because we saw that the grains are permanently distorted. So the recrystallization do not take place in cold working. So because the grains are permanently distorted. So due to the grain size is removed, that is under the category of recrystallization is not considered for the cold working process here. Third one, that is during the cold working, residual stresses are set up. So during the cold working, the residual stress are set up, as their presence is undesirable or suitable heat treatment is given necessary to neutralization these stresses and restore the metal to the original structure. So there are some advantages we are finding that with the working of the cold working. There are some good terms we related for that. Fourth one, that is the cold work forming is most suitable for asymmetric components such as a shaft component, flag component, a finished gear, and the bearing rest, etc. So these are the some we can say that cold work forming is most suited for the cementic components. So the shaft component, flat components, these are the some finished gear are fabricated by the cold working processes. With the help of this, you will be fabricate the all other terms which are discussed in the slide. Now the second part, that is the hot working process. We understand that is when plastic deformation of metal is carried out at temperature above the recrystallization temperature. When plastic deformation of material is carried out at temperature above the recrystallization temperature, the process performed on the metal are termed as hot working, is known as the hot working process. So what the difference between the hot working we will discuss in the later, but what is the meaning of hot working, how we can indicate this is a hot working process. There is a representation by the hot working process, metal are plastically deformed. Metal are plastically deformed above the recrystallization temperature, where above mentioned are here, and when the cold working below their crystallization are mentioned. So they term to be above and below. The below, if you can say, the cold working are indicated, and we can say the above the recrystallization temperature, that means the hot working are placed. So being the above the recrystallization temperature allow the material to recrystallization during deformation. The various hot working processes are: first is rolling forging, second pipe welding, hot spinning, third is the hot extruding, etc. So these all are the processes we are discussing in the hot working process to understand the principle of hot working, and how we can indicate the that is hot working is better than the cold working. There are all the difference between the individual. We will discussing later for that, but we'll first discussing in the hot working processes are three, that is rolling forging, second is pipe welding, hot spinning, another is hot extrusion. So these are the diagram of the hot rolling process. You can see in this diagram what happens. These are, you can see here, these are the original old grain structure. You can see here, these are the old grain structure, and these are the direction of the feeding of the roller. These are the upper roller, and these are the upper and the lower roller. Both are placed on the surface of the material, and applying some certain force on the material with the high speed. And you can see here, these are the original area of the material with a large in the grain the size. And after that, you will when apply the forces on particular area by the roller or continuously remove area to reduce diameter, and you can form that these are the new structure of form, which are in the new crystalline structure of formation. That is, you can see here, this is the smallest structure of form, which is the good or its very strongest bonding are having. That the good mechanical property and strength are producing with the new shape or form. So these are the some working of the hot working process. Below, these are the above the recrystallization formation. That is the important part we will mention during the metal cutting and metal formation, or we can say that the forming of metal by applying some certain forces on the upper and the lower part of the point we attract to contact with the roller, where to reduce the diameter and the formation of the new crystalline. If you check the microstructure of the first or existing to a new, that there are a lot of difference you can find out by the helping the microstructure point of view. These are the some benefits you will be find out by the material. There are the advantages of hot working. So now discussed. First is the high production rate since the process is faster. So these are the some advantages. That is the high production rate is required as a very say that when production rate is very high, the number of parts are will be fabricated very fast and easily fabricated. Second, it is a very high reduction is possible without fear of fracture. Very high reduction is possible without fear of fracture. It is the good, and we can say very main advantages of the hot working process, because without any fear, without any fracture, with the reduction is possible. At this. Second, it is the metal is made suffered because pores get closed and impurity are segregated. Yes, definitely, because in this, you can see in this diagram, that is in the exceeding existing material, the original shape, they are the larger the grains are in the, they are not close to each other. But in the smaller grains, they are close to in an interleaved part we are fixing. So these are the some benefits we will be discussing the part of the hot working advantages. For that is deformation energy requires low, hence the less powerful equipment are required. Deformation energy requires low. That means we can say the less power equipment are required for that particular operation. If you are doing the hard working, and for that your deformation will be required is very low, because it will not again it will not deform easily. If this structure can be altered to improve the final properties, basically the structure altered can be improved. Yes, obviously improving, because as you see in this diagram, these are the existing structure, and after these are the structure, new structure form. Yeah, you can see these are the lot of difference between them. So this pointer will be true. That is improving the final property is very important. The part of that structure will be changes is too much. So this is very helpful for to making the new grain size with a strong bonding of a metal to providing the high strength of mechanical the material. Sixty, the processes does not changes hardness or ductility of the metal, since distorted grind, so change the new and deformed grains. So they do not change the hardness or ductility. This is the main advantage during the maturing process, or during the metal forming process that we are doing the hot working. There is no changing in the we can say property of these are the good advantages. Because sometimes what happens when you are doing the any apply the force, and some grains are disturbed internally, and they change their strength and weakness. So these are the some response are the diameter which will be considered. That is no changing in any. There is no changing in the microstructure. There is no changing in the we can say hardness. It is the good advantages of the hard working. Seven, it is the interstages annealing and stress revealing are not required. Interstage annealing and stress are revealing not required, because it not needed, because during the cold working when the roller are run on the upper and the lower side of that particular point, it will be reducing the stresses and improving the quality of the strength of the particular material, which is not required for the revealing. Eighth point, it is the since hot working promotes diffusion of constituents, segregates can be reduction or eliminated by the, we can say hot working is very responsible parameter, and it is very good for that. So diffusion of the constituents and segregate can be reduced, eliminated, which will unwanted impurities will be eliminated by this type of hot working if you are doing for a particular metal, for increasing the enhance the property of a metal by heating continuously at a certain temperature, and after applying the roller, because due to this generally it will application on the rail steel. If the rail steel you can say the rail track we are made, we are fabricated, and you are just doing the hot rolling and cold rolling, it will be helpful for you to understand the hot working will really helpful to increasing the quality, increasing the strength, and to reducing the shape, or to increasing the grain size with the new formation of material with crystallization form. So these are the several advantages of we can say that are you mention for the part of hot working process. So the disadvantages, if we say that disadvantage, that is also that there are some disadvantages of the hot working also. So that is the first is handling of material is not too easy. That obviously that is handling is not easy, because they are working the hot temperature. They are too much temperature applying for the material, and to increasing the temperature, it's very dangerous to be easily handling. So it will be prevent some precautions will take place for the, and especially skills be required for to doing the hot working process. Second is the heat resistance tools are required, which are expensive. So heat resistance tools are required, which is expensive, is the part of material we can say that the too much expensive processes are, because of maximum temperature, maximum heating are required, furnace are required, and some water we required for in the roller having special capacity. So these are some expensive tools required for the operating the hot rolling process, hot working process also. Third one, that is high temperature may promote undesirable reaction. These are also because of under temperature, high temperature we are working for that. Hot close tolerance cannot be held because of non-uniform cooling and thermal contraction. Surface finishing is poor because of scale formation. There are some type of will be surface finishing will be poor. Sometimes it will be high. Six is meteorologically structure may be non-uniform because of cooling history after deformation. After completely the, you can say after completing hot rolling process, and you will be transferred for the cold rolling for, because of cooling the history of the deformation, because it will after not it will sometime it may be chances that during the high temperature the microstructure will be changes. So this for the reducing of for awareness, you will just transfer to the meteorological structure may be non-uniform because of cooling history after deformation. Following points are worth noting for the case of hot working, such as our hot working processes can be considered as simultaneously combination of the working metal and annealing. And its work hardening effect caused by the plastic deformation is neutralized immediately by the effecting of the high temperature. And the hot working, this proceeding the facilitated effect of the zapping with the lower powerful required to it is expensive to handle, not material. Third one, that is it in hot working, there is a loss of metal by scaling and the fine dimensional tolerance cannot be achieved. These are some points to be considered. Hot rolling. And fifth one, that is a hot working, increasing the density since any processes of cavity in the cast metal appearances. So at the end we are comparing the hot working process and the cold working process, that how much difference between the both this process if you are working on this. The cold working in case we have first point, it is a cold working is done at the temperature below the value required for recrystallization, so no appreciable required recovery takes place during the deformation. And in the case of the hot working, there is a hot working in done of the temperature above the recrystallization temperature. Second point considered is the hardening is not eliminated as working is done at temperature below the recrystallization. And here the hardening in the case of hot working, hardening due to the plastic deformation is completely eliminated by recovery and recrystallization. Third point, that is the cold working decreasing the value of elongation reduction area impaction value. In the case of hot working, mechanical property like elongation, reduction of area, impact value are improved. In the case of cold working, the uniformity of material is lost and property are affected a lot. In the case of hot working, the promote uniformly material by facilitated and the fraction of the alloys consisting on the impurities. And the sixth point in the case of cold working, that is changes of crack propagation is more, and in hot working, that is crack and unoxidized below the hot are sometimes welded up. So there is some difference between the tensile property also in the case of cold working and tensile increase in ultimate tensile stress and the yield point and hardness, fatigue strength, and ultimate tensile strength, yield point, fatigue strength, hardness, resistance to corrosion are not affected by the hot working process. So these are some advantages and disadvantages for the both hot rolling, hot working and cold working. 8 point, internal and residual stresses are produced, and in the case of hot working, internal and residual stresses are not produced. 9th is the energy required for plastic deformation is more, and in the case of we can say hot working, the energy required for plastic deformation is less. 10th point is the more stresses is required for deformation, and in case of hot working, less stresses is required for deformation. 11th is no oxidation of metal occur during the working, and hence picking up it not required. And in the form of hot working, there is a heavy oxidation occur during the working we required for the. So these are some basic required we can comparison of hot working and cold working. At the end of this lecture, I am just asking some multiple choice questions to related with the cold working, hot working. So let us start. The first is the cold working of the metal is accomplished at the options are A, below recrystallization temperature, below recrystallization temperature, above recrystallization temperature, and any of them. So the answer is A, recrystallization temperature. Second point, second question, that is which of the following is not improved by cold working metal? First is hardness, second toughness, C, surface finishing, third is corrosion resistance. So the answer of correct answer to the question is D. And the corrosion resistance is not improve the cold working of metal. Third point, depending upon the temperature of forming process can be classified as the options are hot working, cold working, warm working, and all of the mentioned. So the correct answer is D. All of the mentions are true for the temperature forming process for the metal. Fourth is if temperature of metal melting point is then is hot working, the value of the metal is A 0.5, 0.6, 0.4, 0.7. The correct answer that is 0.6 are the value we related for the material. Fifth question is in which of the following processes no strain is hardening is reproduced? A hot working, B cold working, C warm working, and D cannot say. The correct answer of this A, that is hot working, the no strain hardening is produced. Sixth question, that during the hot working, the grain growth can take place in which part of the material? The options are exterior, B interior, along the edge and side faces. The correct answer for this is interior, or the part growth we can say that can be take place in the part of the material. Seventh question, which of the following defect is eliminated by the hot process X processing? The options are A, cold shed, misrun, below fall, fusion, and the correct answer is C, that is a blowholes. Eighth question, the working principle, the working temperature of cold working is below a certain temperature. That temperature is known as A, critical temperature, B, recrystalline temperature, C, transition temperature, and D, Curie temperature. The correct answer for the question is B, recrystallization temperature. Ninth question, in which of the following process the ductility of the material decrease? The options are A, hot working, B, cold working, C, warm working, and D, cannot say. And the correct answer of this B, cold working. And last question for this lecture, that is which of the following statement is true about the cold working? The options are A, strain hardening is relevant, B, non-oxidation occur, C, only limited amount of reduction can be done, and D, cost of machining is high. And the correct answer for this that is strain hardening is relevant. So, and at the end of the lecture, I am preparing some books to recommend also to you, and for the understanding the metal forming chapter, that is the book's name as the Principle of Manufacturing Metals and Processes by James S. Campbell, Tata McGill publisher. Manufacturing Technology, Foundry, Forming, Welding by M.J. Rao, Tata McGill publisher. Production Engineering Science, that is P.C. Pandey, C.K. Singh from the Strand publisher. Fourth, Manufacturing Technology by R.K. Rajput by Lakshmi publication. And Manufacturing Technology by P.N. Rao from Tata McGill publication. So if you in doubt any query, you will be asking me on my drop my email ID amit.tiwari@mygyanway.com, and you will also contact my mobile number at 690319448. Thank you so much for listening patiently. I hope you enjoyed this video. Thank you.